All right, SAT 2021, April. This is the no calculator section. Let's get right after it. The graph of a linear equation and the graph of a quadratic are shown. So the linear equation is right here. The quadratic is this parabola going up. What is true about the point -1, 4? So if we go over to -1 and up 4, we get this dot right here, this point right there. What's true about that? Well, since it lives both on the quadratic and on the line, that means that it satisfies both equations. You know, if they were to give me a point over here, that would have just had one solution. That would have only satisfied the quadratic and not the line. All right, moving on down to number 2. A ball is thrown upward from a height of 3 feet above the ground, assuming there's no air resistance. We have a function f defined by, so let me just kind of write this down and explain this notation a little bit. H of t is -16t squared plus 36t plus 3. And the t, right, what's right here? This is the input. And h, whatever h ends up being, is the output. So we can put different t values in and get different answers. And it says right here that the height is h, and t is the seconds. So we can input a time and figure out the height of this ball. So it says, hey, what is the meaning of h of 2 equals 11? So what that means is our input, since 2 is time, that means that we're putting 2 seconds into the equation. Now, we don't really have to do this, but if I wanted to work it out, I could plug the 2 in everywhere where I see the t and evaluate that and calculate it out. And it looks like it turns out to be 11. So that means after 2 seconds, our ball is 11 feet above the ground. And they have various combinations here of the 2 and the 11. But the correct answer here would be C. Moving down to number 3, which expression is equivalent to, they have a couple algebra expressions here. The big thing you want to be careful on is whenever you see this subtraction, all right, you got to remember to distribute. You need to kind of distribute that negative through. So I'm going to rewrite this as 4x to the 5th plus 5x to the 4th. There's no need we can drop the parentheses because there's really just a positive 1 there that does nothing. Now, this -1 though, when I put this -1 in here and I distribute the -1, that's going to give me a -2x to the 5th. And then that's also going to give me a -3x to the 4th. So now I have a new expression. I need to combine some like terms. So I need to kind of see who goes with who. And these are x to the 5ths, and I have other x to the 5ths. So a 4 and a -2 gives me 2x to the 5th. And then I have the 5x to the 4th, a -3x to the 4th. That's a +2x to the 4th. These are not like terms, so I am finished. Correct answer there is B. All right, number 4, at sea level, the boiling point of water is 212 degrees. For every 500-foot increase in elevation, so the higher you get, the boiling point decreases by a degree. So if you're 500 foot above sea level, water boils at 211. If you're 1,000, it boils at 210. Which equation models the water's boiling point, Y, in Fahrenheit, in terms of X, the elevation? All right, so let's kind of think about our graph here. So if we have some sort of graph, the Y represents the Fahrenheit, and X represents the elevation in height there. So it says for every 500-foot increase in elevation, we are going to decrease by 1 degree. So that means that, at 0, we're at 212, at 0 degrees above sea level. And then as you go over to 1 degree, or actually as you go up 500 feet, all right, to 500 feet, we drop to 211. So kind of put a dot, right over here. If we go up another 500 feet, 1,000 above sea level, we drop another one, and so on and so forth. So you have this really flat line kind of going that way. And if you look at all of these, they're all written in the form y equals mx plus b. All right, and remember, this is the y-intercept. That's what the b is. The m is the slope or the rate of change. So it looks like our y-intercept is right up here at the top. So our y-intercept is a positive 112 or 212. So that wipes out these two because they both have negative 212. So now we're down to either A or B. And remember that slope is the change in y. That's a Greek letter, delta, represents change. The change in y over the change in x. So we are dropping 1 as we're running 500. So we drop 1, we rise, we run over 500. We drop another 1, 500. So our 1 goes on top and our 500 goes on bottom. So the correct answer here is A. This one is just a little tricky because normally you'd probably put temperature on the bottom and elevation on the side. And they kind of reverse those two, the x and the y, which made it a little bit trickier of a problem. Number 5, this looks like a laws of exponents problem. It says which expression is equivalent to 12x to the third over 8x squared. So a couple things about laws of exponents. The numbers you just kind of do like you normally would. So I just kind of first focus on just the coefficients or the numbers in front. 12 over 8, both of those numbers can be divided by 4. So I'm going to get a 3 on the top, and I'm going to get a 2 on bottom. So right there, if I peek at my answers, pretty much that eliminates everybody, and I didn't even have to know anything about exponents. But I might as well finish it out while I'm here. The exponent part, whenever you divide powers, so if you're doing x to the third divided by x squared, which is what that bar right here represents, you actually subtract them. So you subtract the exponents, which would be x to the first or just x. I like to sometimes think of it as, another way to look at it is on the top, we had x to the third, which is x times x times x. And on the bottom, we had x squared, which is x times x. And then you're allowed to cancel anything that's on the top and the bottom. So you're kind of left over with 1 on top. But either way, correct answer here is B. Number 6, we have some values of x and the corresponding values of f of x in the table shown. So just real quick, f of x is just really y. So on all these problems down here, you can just pretend that this is y equals. And it says they form a linear relationship between x and y. Which of the following gives this relationship? So we have some points, we have some equations. You could plug these values of x in and see which y values you get. That's going to take you a little while. Probably not the fastest way to do this. You could graph this problem and plot these points on a graph. The problem is I think some of these y-intercepts are awful close to each other. So I'm going to kind of go this route. We know that lines are in the format of y equals mx plus b. And we know that this m is represented by slope. All right? And the slope, a lot of people say it's rise over run. I like to look at it as the change in y over the change in x. So when you're looking at your graph, as y goes up by 1, all right, from 1 to 2, so as our change in y goes up by 1, positive 1, our change in x goes up by a positive 6. So right there, that tells me that our slope is 1/6. So when I think back to my original equation here, I know it's y equals 1/6 x, but I don't know what b is. I don't know the y-intercept. So immediately I can eliminate a and b, and I'm down to 2 choices. And both of these y-intercepts are so close to each other, 5, 6, and 2/3, that I don't think graphing would get the job done. So I need to do what's called solve for b. So I'm going to try to solve for that y-intercept. Well, how I can solve for b is I'm going to plug in a nice x and y to figure out what b is. And I have some solutions over here. I can pick any of these I want. I think this is a really nice combination to put in. So when y is 1, x is going to be 2. And I'm then going to figure out what this b is over here. So let's finish the equation. 1 equals, well, 1/6 times 2 is really just 2 over 1, and I can multiply straight across and get 2/6 or 1/3 plus b. And then to figure out what b is, I need to minus that 1/3 from both sides. And I get b equals 2/3. So the correct answer here is going to be D. Number 7, it looks like they give us another linear graph. It says line M is shown up above. Line P, which is not shown, is perpendicular to line M. Which of the following could be the equation of line P? So basically all of these equations down here, these people down here, this is line P, which is not shown. And remember a couple things vocabulary-wise. Perpendicular means 90 degrees. All right, so we need to be 90 degrees to this line. So, you know, it's going to kind of come in and hit something like that and make a 90-degree angle. So there's a couple things we can get from that right away. One, and maybe I should put this in red since I kind of wrote P down there below. But if I'm going to have some line coming through and hitting this at 90 degrees, number one, it's increasing from left to right. So I need to have a positive slope. So these are the type of big concepts that can at least give you a guess if you're not sure on some other things. But a positive slope, this right here is negative, this right here is negative. So right away, just by knowing that, I can get this down to a, to a 50-50. But we can do a little bit better than that. So let's kind of go through and show you how to do this. So I'm going to get rid of this here, and let's focus on the line that we have. So why don't we find the slope of line M? This blue line right here. Let's get the slope of that line. And all we need to do is find a couple lattice points where you cross perfectly at a corner on the grid. And since this line is decreasing, I know it's going to be a negative slope. And the change in y is 2, and the change in x is 1. And remember, slope is always change in y over change in x. So the slope is going to be -2. Now, if I want to be perpendicular, all right, there's two things you need to do to change the slope if you're going to be perpendicular. All right. Number one, you always need to change the sign. All right. And number two, you need to do the reciprocal, or some people just like to say, we need to flip that slope. So if this was the original slope, if I want to be perpendicular, I need to change the sign, and I need to flip it, or be the reciprocal. So I know the slope is 1/2. So this one right here has a slope of 2, so it can't be U. Correct answer is going to be A. All right, number 8, I have a graph here. We've got number of goats on the y-axis, number of horses on the x. The line shown models the possible combinations of the number of goats and horses on a 10-acre farm. Based on the number of acres of land each animal needs, based on this model, how many acres of land does each horse need? All right, so this problem's kind of worded weird, but let's just think of it. So we have a 10-acre farm. I'm just going to draw this out. All right, so this is a 10-acre farm. And we have combinations. This line right here shows combinations of what could happen. So for instance, if I pick a point, if I pick this point right here, well, that point represents 60 goats and 0 horses. All right, so that means in 10 acres, I could have 60 goats, but I couldn't have any horses. All right, and at the other extreme, if you come all the way down here to the bottom, the other extreme right there, that means if you have 5 horses, then you can have 0 goats. And then there's all the combinations in between. So in this 10-acre farm, at most I can have is 5 horses. All right, so again, I got these 5 horses out here just kind of chilling. So it says, based on the model, how many acres of farm does each horse need? Well, if there's 5 horses for 10 acres, that means 1 horse requires 2 acres. It's kind of a proportion problem. So every horse requires 2 acres by himself. So the correct answer here is A. All right, number 9. Looks like we have an inequality here, and it's a linear inequality. It's going to be a line. I'm going to give you 2 ways to solve this. It says, which of the following ordered pairs, x comma y, satisfies the inequality above? So remember, these points, this is basically like if you had a little table here, 0 for x and 3 for y. If you were to plug that in, you want to see if it's true. And you say, okay, is 3 less than 0 take away 4? And you're asking yourself, does this work? Does it satisfy it? Well, if you actually calculate it out, you'll get 3 is less than negative 4. And that's false. That's a false statement. And you'd have to go through all of these and test them all. And typically with these type of problems, you'll see the answer down towards the bottom because they know most kids are just going to plug those in. And they're going to make you work for it and use up some time. Another way to do this problem would be to graph this. So if I start off kind of with my XY grid, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Well, I'm going to pretend that I'm going to graph the line y equals x minus 4. And this is pretty, not too bad to graph because I have the y-intercept. There's my y-intercept, so I cross at negative 4. And my slope is the coefficient in front of x, so my slope is 1, which basically tells me to go up 1, right 1. So I'm going to go up 1, right 1, up 1, right 1, up 1, right 1, and so on and so forth, all the way through. And you're going to have this line like that. And technically, because it's less than, this doesn't really matter on this problem, but it should be a dotted line. All right, but it really doesn't come into play here. And then here's kind of a big trick, and this works on harder problems. This symbol is very important. When you see y is less than a line, that means you are going to shade below the line. All right, so that tells you to shade below. So that would be all of these points here. Everything on this side is a solution that works. So for instance, if I look at these points, if I were to try that first one, 0, 3, well, 0, 3 is here. That does not live in the solution region. 3, 0 does not live in the solution region. 0, 6 does not live in the region. 6, 0 does. 6, 0 is going to be right over here, and that one does live in the region. And also, if you were to plug those values in, 6, 0, this would be a true statement. 0 is less than 2. So you could go the plug and chug or you could graph it either way, but I do think this fact about y less than you shade below and y greater than you shade above is definitely helpful, especially in problems where there's a system of equations and there's 2 lines. So I thought I'd kind of throw that out there to you. All right, number 10, right triangle PQR. The length of side PQ is 70, the measure of angle P is 90, and R is 38. Which of the following is the length of a side? And right away when I see sine, I'm like, oh, this is trigonometry. So if you're trying to study more about this type of problem, it's going to be in the trigonometry section. And first thing I need to know is, since they're all referring to sine, the sine of some angle, all right, the sine of some angle refers to the opposite leg over the hypotenuse. Okay? And you may remember from previous class, SOHCAHTOA. And the C and the T represent cosine and tangent. So those are other trig ratios. So let's draw this thing. The big fact I see is that angle P is the 90. So I'm going to make a right triangle. And I'm not really going to worry about the sides and who's longer or smaller. That'll all shake out in the wash. But angle P is 90. Q and R, the other people, not really going to care who goes where. I'm just going to kind of put them down. Now the length of side PQ is 70. So this side over here is 70. The measure of angle R is 38. So 38 degrees down here. Which of the following represents the side QR? Well, QR is this side right here. And for this particular problem, I'm going to call this is going to be my X. This is going to be what we're after. Well, looking at what I have, I'm going to stand, so this kind of how I do trig. I put my guy on the reference angle, on the angle that's given, since they give me 38. I'm going to put my guy there. And now I need to label the triangle. And I need to label the triangle opposite, adjacent, and hypotenuse. So across from me, this is the opposite side. The side that I know nothing about, this is the adjacent, or right next to me side. And then across from the 90 is always the hypotenuse. So if I'm trying to solve for x, what I'm going to do is I'm going to set up this sine ratio, because the sine, when standing on 38 degrees, that's my reference angle, is the opposite leg divided by the hypotenuse piece. So now I have a trig equation that can be solved. The easiest way I think to solve this would be to put a 1 underneath here and then cross multiply. So I'm going to cross multiply. 1 times 70 is 70. X times the sine of 38. And then if I want to solve for x, get x all by itself, I have to do the opposite of times sine of 38. So I need to divide by the sine of 38 degrees. And divide by the sine of 38 degrees. So that way this cancels. And x is just going to equal that expression there, which is B. All right, number 11 is a really tough problem. We have an equation up there, and it says the graph of the given equation is a circle. What is the radius of that circle? So a couple things you need to know, and I have other topic videos just on circle equations, and this is actually even a really hard circle equation problem. But first of all, let's just talk about the equation itself. So in general, this is the equation for a circle. X minus h squared plus y minus k squared equals r squared. And, you know, in general, maybe I should even come down further. In general, if you just have x squared plus y squared equals r squared, this circle is going to have a center at 0, 0, and r is going to represent the radius. All right? So, for example, just really quick, if I had x squared plus y squared equals 16, I could graph that. It's basically a circle centered at 0, 0. And since r squared is 16, that means that r would be the square root of that, which would be 4. So the radius would be 4, and I could come out 4 in every direction, and I could draw, you know, a nice little circle. Well, if you want to start moving it left, right, up, and down, that is where the parentheses here come from. And so the general equation up above, so I'm going to kind of get rid of this bottom part just because I need a little bit more room. But if you look at the part up above, this circle, this is a little more advanced, this circle has a center at h comma k and a radius there at r. So this is where if I want to move it left or right. Here's kind of the hard part. This equation is not written in a nice perfect square kind of format. So here's what I'm going to do. I have x squared minus 6x. And then I'm going to separate, and I'm going to do the y's over here. Y squared minus 8y. And then I have equals 0. And what I'm going to do, this method that I'm about to use, you could look up in some other videos on complete the square. Not the quare. Complete the square. And this kind of goes back to Algebra 2 and quadratics. So they're combining a lot of skills right here. But to complete the square, it works something like this. I want to get a perfect square. I want to have this come out to be, x minus something squared. And I want this other one to come out to be y minus something squared. Because then it'll be in the right format for a circle. So how I can make a perfect square is, what you do is you take this middle term, and I'm going to cut it in half, which would be a minus 3. And then I square it to complete the square. Well, a negative 3 times itself is a positive 9. And if you were to factor this expression, it would just be x minus 3 squared. All right? So I'm making it so it'll factor perfectly. Well, over here, if I cut this value in half, minus 4, and if I square it, I get a plus 16. Now, I'm not allowed to just start changing equations. So since I added 9 and I added 16 to the left side of the equation, to keep this balanced, I have to add that 25, 9 plus 16, to the other side. So now my equation stayed balanced. So now I have a new equation right here. And that equation tells me quite a bit about the circle. That tells me that my h value is 3, my k value is 4, and r squared is 25. So what I've just done is I've just graphed a circle that has a center at 3, 4. It moved 3 right, 4 up, and has a radius of 5. And for this question, all they want to know is the radius. So the correct answer there is D. This is the hardest circle equation problem they will give you. And I have seen several that I would say out of 25 SAT tests, this is probably the 6th or 7th time you've had to complete the square on a circle equation. All right, number 12, they kind of give me a little bit of a complicated looking equation. But the main concept right here is, what is the y-intercept? All right? And I'm not going to worry about the equation just yet, but think about a line. Like if you just go back to good old school linear equation, y equals mx plus b, b represents, this n number represents the y-intercept. And the y-intercept lives somewhere on this line. It could be any one of these places. It could be a y-intercept. But the key fact you need to know is that a y-intercept has an x value of 0. All right? I don't care where you live on this line right here. When we put your coordinates in, it's going to be 0, something. All right? So it's kind of like if you wanted to make a table, it's basically saying, hey, if x equals 0, what does y have to be? So if I go over here to my equation, even though this one is more complicated, this is a quadratic, I know that every y-intercept has an x value of 0. So I'm just going to plug 0 in and see what y has to be. So 0, I do parentheses first. 0 take away 4 is a negative 4. Keep parentheses around there. Square that number. So a negative 4 times itself is 16. 16 plus 3 equals 19. So when x is 0, y is 19. The correct answer here is D. All right, number 13, this is a function notation, f of x. Remember, f of x really just means y. So don't get hung up on the f of x. So y equals x squared plus 4x plus 4. So I know this is going to be a quadratic. It's going to be something that looks like this. Because there's a positive number in front of x squared, I know it's going to open up. If it started off as negative x squared, I would know that it opens down. But this problem, it opens up and it says, for the given function f, what is the minimum value? What is the lowest value of y, or of f of x? So the minimum value occurs right at the very bottom of this parabola. That's the lowest y value possible. So we're trying to find the vertex. We're trying to find that very bottom piece. And there's several ways to do this. There's actually 3 that I can think of right off the top of my head. So let's just get right after it. If you're completely stumped and you don't know what to do, my thing is always just make an XY table. Okay, this is kind of method 1. Don't have a clue, just start putting some numbers in. So let's put 0 in for x. And if I put 0 in for x, I get 0 plus 0 plus 4. So there's a value that I could kind of put on a grid. And I'll just slip it down here. So I know that 0, 4 is right there. Well, let's go over to 1. If I put 1 in there, I get 1 squared plus 4 times 1 plus another 4. Well, that comes out to be 9. So I'm getting bigger. So when I go over 1, that puts me all the way up, 5, 6, 7, 8, 9. Puts me way up here. So let's go the other way, because I think we want to come down this a little bit. So let's go to -1. If I put that in, I get -1 times itself plus 4 times -1 plus 4. And if you're good at mental math, this can be quick. If not, using a calculator, this can be kind of slow. But I got 1 minus 4 plus 4. Ooh, so I'm dropping down. At -1, I'm up at 1. Well, let's go a little bit further. If I go to -2, so -2 squared plus 4 times -2 plus 4. Well, that comes out to be 4 minus 8 plus 4. Well, that's 0. So at -2, I'm down here at 0. And I could go one more just to be safe if I wanted to put a -3 in there. -3 squared plus 4 times -3 plus 4. Well, that's 9 minus 12 plus 4. And that comes out to be 1. So now I'm going back up again. So I think I've kind of established the minimum value for y. The minimum value for y is right here at y equals 0. So the correct answer is D. Now, there's a lot faster way to do this. You could factor this really quickly. So if you're good at factoring, you have y equals x squared plus 4x plus 4. And this factors out, if I'm trying to find two numbers that add or that multiply to make that number and add to make this number, well, x plus 2 times x plus 2 would work. All right? And so if I set that equal to 0, I actually get to what's called the zeros of the function. And once I have the two zeros of the function, I see that, oh man, there's a double 0 here. You know, there's a double 0 at x equals -2 right there. So whenever you get a double root like that, that means that it comes down and it just kisses it and it bounces right back up. So I know that this one had to have a minimum y value of 0. If you're doing other problems, this can be kind of helpful. Just because, like, let's say you have an equation like y equals, I'm just going to make up an easy one here, plus 3x minus 10. Well, if I wanted to factor this one, two numbers that times together to make -10, but add together to make +3, well, I could do a +5 and a -2, which gives me two zeros. And those zeros become helpful because then I can put one 0 like right here at 2, the other 0 at -5, and I know that this thing comes down and goes back up. So it's kind of helpful for finding where your vertex is, because my vertex is going to be exactly in the halfway point of that. And since there's 7 spaces there, or I could just average those two numbers. You know, this one's going to be a decimal. I kind of picked a bad example. But it looks like at -1.5 is going to be the very lowest spot. And you could plug in x equals -1.5 to figure out the y value in this equation right here. But however you want to do it, either way would be good. There's even other ways using standard form graphing, but probably a little bit longer. All right, which linear equation has exactly one solution? Well, let's try to solve these out and see what we get. So on this first one, if I add that y to both sides, this is gonna cancel. I'm gonna get 2y equals 5. Divide both sides by 2, and I get y equals 2.5. Well, there's one solution. On this next one, if I minus y from both sides, I get 0 equals negative 5. Well, my y has disappeared. That's a false statement. So this one would be no solution. On the next one, if I minus the y from both sides, I get 0 equals positive 5. False statement. That equation has no possible solution. And this bottom one, if I take away y from both sides, I get 5 equals 5, which is a true statement, but that means I could plug anything in for y. So that is infinite solutions. So it looks like the only one with one solution was A. All right, number 15. This one is a little bit tougher problem, or it can be tougher, but I'm going to kind of cheat it a little bit. So it says, what is the graph of y equals 4 minus 2, parentheses, 0.5, to the x power? So right away, I want you to realize that when you see that x up here as an exponent, this is an exponential equation. And after I show you how I kind of cheat this problem, I'll kind of go a little bit more in depth on how you handle these. But one thing that you need to know is you could just simply, again, my go-to method, a lot of times this is faster than everything else, just make a table. All right? So let's plug 0 in for x. So if I plug 0 in for x, I get 4 minus 2 times 0.5 to the 0 power. Well, you do need to remember the rule that anything to the 0 power is 1. And 4 minus 2 times 1 is 2. So I know that this point right here, I know that 0, 2 is a solution and it lives on the graph. Well, 0, 2 does not live on this graph. 0, 2 does live on that graph, so he's still fair game. 0, 2 lives here, fair game. 0, 2 does not live on the graph. So right there, just that little fact, I got it down to a 50-50, which is really important on this test. Well, I'm going to go a step further. I'm going to put 1 in for x. All right, and I'm going to repeat the process. So I have 4 take away 2 times 0.5 to the first power. So do exponents first. 0.5 to the first power is 0.5. 4 minus 2 times a half. Well, 2 times a half is 1. So I know that 4 take away 1 is 3. So I now have another point that has to live on the graph. It's 1, 3. So out of my two choices that are left, over 1 up 3 does not live on this one. Over 1 up 3 does live on this one. Correct answer is C. Now, that's a really quick way that I could just cheat that problem, not really know anything about the graphs of exponential functions, but just use my little table. I will kind of break this down a little bit, but exponential functions, typically when you have something like, I'm going to rearrange this a little bit, y equals negative 2 to the 0.5 to the x power, and I'm going to put that constant 4 at the back. I'm going to show you why. So here's what all these numbers do. So this back number, pretty much with all graphs, tells me that I'm going to move my thing up 4 units. So whatever graph I have, I'm moving up 4 units. Well, normally, this is going to be your starting value. Okay, that's going to typically be a starting value for a problem, the 2. And this negative is going to tell me whether I reflected or not. And so typically, like when you have exponential growth, and it goes like this, kind of starts slow and grows fast. So this is exponential growth. And exponential decay kind of comes down like that. So this is exponential decay. Well, how you know whether it's growth or decay is inside this parentheses here. And it's decay if you're less than 1, and it's growth if you're more than 1. You know, if you think about it, if you multiply a number by 1, it stays unchanged. If you multiply a number bigger than 1, it starts growing. If you multiply a number by a number smaller than 1, it gets smaller. So I knew this graph was going to be decay. I knew it was going to drop. All right? So right now, I can kind of ignore this thing going up. Well, then I also know that because this is negative, there's going to be a reflection across the y-axis. So that means if you kind of put a y-axis here, this one is actually going to reflect, and it's going to look something like that. So that fact right there wiped out these two up top. And now I know that it's got to be shifted up 4 units. So that kind of helps me out too. So I'm going to be shifted up 4. And that's going to kind of help because I started at -2, but we shifted up 4, which is going to put me right here. So that's another way to know that the correct answer was C. But I believe my little XY table was way simpler. All right, number 16, in the triangle SRT, T is 40, R is 20. What is angle S? This problem goes super fast. I'll just draw some random, triangle, RST. If T is 40 and R is 20, how much is S? Well, all triangles have to add up to 180 degrees. So right now, we have 40 plus 20. So right now we have 60. So that means angle S has to be 120 degrees. Number 17, looks like I just have a basic algebra equation. What value of x satisfies it? So we have 3x plus 2, or divided by 2, plus 4 equals 13. Well, this is where the x is. This is my variable term. So I want to isolate the variable term. I want to get that by itself first. So the first thing I'm going to do is I'm going to subtract this 4 from both sides. And when I do that, I end up with, that cancels out. I have 3x divided by 2 equals 9. And to get rid of the divided by 2, I'm going to multiply both sides by 2. So I'm going to times this side by 2. I'm going to times this side by 2. And basically the times by 2 and the divide by 2 cancel. So now we're left with 3x equals 18. And now I just divide both sides by 3. And we get x equals 6. Now, some people right here, when we had 3x over 2 equals 9, some people right here, instead of doing the times both sides by 2 move, they would rather just slap a 1 under here, and then you can cross multiply. And for a lot of people, that's a much cleaner, easier way to do it. And you're still going to get x equals 6 if you go that route. All right, number 18. You don't see this a whole lot, and it could be a long time maybe since you've seen this, but these bars refer to absolute value. These don't even always show up on a test. If they do, I only see one of them. But absolute value basically refers to as the distance away from 0 on a number line. You know, so if they were to say, hey, what is the absolute value of -7? Well, the answer to that would be +7. Because all it's really saying is if you have a number line and you have a coordinate at -7, it's just wanting to know what is the absolute distance, what is the value of that distance from -7 to 0. Well, and you also, if they were to say what's the absolute value of +7, that also gives you an answer of 7. You know, so if they were to say, hey, what is the absolute value of 7? That's also 7. Moral of the story is whatever's inside the bars, you just make it positive. So if you think about this problem over here, when they say the absolute value of x plus 1 gives us an answer of 5, well, we know that there are two things inside here that could give us a +5. either x plus 1 is really a negative 5, you know, because the absolute value of negative 5 would be 5, or x plus 1 could turn out to be a positive 5. Either way, we're going to end up with an answer of 5. So we just got to solve both cases. So we do x minus 1, so we get that. Or if I solve this side, we get this. And it says what, here's where it says, what positive value satisfies the equation? So since this is a negative value, this is the positive value, and we're good to go. Number 19, this is an equation that we have to solve, and this would fall into the category of square roots and radical equations. So if you're struggling with this and you need more work, here's where you might want to go and look for some extra help. Square roots and radical equations. I see the square root, and if I want to get rid of a square root, the inverse of that is to square it. So what I'm going to do is I'm going to square both sides. So I'm going to take this whole side, and I'm going to square it. And I'm going to take this whole side, and I'm going to square it. And basically, I chose to do that because this square root and this square, they squash each other. It's like right when I do that, it disappears. And I have 14 minus 2x. Now, the right-hand side, I got to do a little bit of work. I need to square that out. So I need to kind of do FOIL. I have to do x minus 7 times x minus 7. I have to expand this or double distribute. Different teachers call it different things. But I have x squared minus 7x minus another 7x. Negative 7 is positive 49. So when I clean that up a little bit, that side comes out to be x squared minus 14x, because I combine these like terms here in the center, plus 49. Well, now I'm trying to solve this equation. Well, I had noticed that it has a 2 in here as an exponent, so it's a quadratic. And when you want to solve a quadratic, you want to set one side equal to 0. So I'm going to get rid of both of these things on this side. I'm going to minus 14 from both sides, and I'm also going to add that 2x. And what that achieves is it gives me a 0 on this side. And combine these out, I get that. Negative 14 and a positive 49, that's plus 35. And now to solve this quadratic, because you notice I have x's in two different spots, so I can't just get x by itself. What I'm going to have to do is I'm going to have to attempt to factor this thing. So here comes the factor game. And the factor game is I need to multiply to make 35, but then the same two numbers have to add to make a negative 12. Well, how can I multiply to make 35? Well, I could do 1 times 35, or I could do 5 times 7. And I think if I pick the right combination, if I pick a negative 5 and a negative 7, that will do both of these things that we need to do. So I have an x minus 5, I have an x minus 7. And now I'm going to use what's called the zero product property, meaning that if something times something equals 0, either this parenthesis is 0 or this parenthesis equals 0. And then I just solve them. So it looks like the two possible answers here are 5 or 7. And now I want to test these two. I want to actually go back and I want to put them in to see if they in fact work. Because sometimes you get an answer that algebra says it's an answer, but when you plug it in, it's not. So let's do this. So 14 take away, let's try the 5 first. 14 take away 2 times 5. Well, that would be the square root of 14 minus 10. All right. Well, that's the, so that says the square root of 4. And if I put in 5 over here, 5 take away 7 is negative 2. Now, anytime in the SAT when they have you take the square root of a number, they assume it's the positive answer. So this is not going to work. 7 is going to be the one that works for us. If we plug that in, we're going to get the square root of 0 on one side, and we're going to get 0 on the other. And this is true. So x equals 7 is going to be your final answer. Number 20, classic system of equations. The SAT loves these type of problems. We need to figure out what is the value of y. I really like how this one is already stacked up for me. So notice I have my x terms in a row, my y terms in a row, my constants or my numbers in a row. So I think we can use a method called elimination. So if you check out some of my systems videos, this is my go-to method for most of these problems. So I need to try to get coefficients to match up. And since we're trying to find y, my goal is going to be to eliminate x. I want to eliminate x. And all I got to do is I want to get the coefficients, or the numbers in front, to be opposites of each other. Meaning I want one to be positive and one to be negative. So check this out. I could get this to be opposites of each other if I multiply this top row by a -4. So if I multiply that whole top row by a -4, I get -8x, -28y, and -16. The bottom row I'm going to leave the same. I'm not going to touch it. Some problems you have to multiply both rows, but this one I get away with only multiplying one. Now, why did I want coefficients to be opposite? Because I'm allowed to add these two rows together. I can add two equations together if I want. And when I add them together, a -x plus a +8x disappears. It goes away. Now if I do so that's gone. -28 plus 4, well that's a -24y. And a -16 plus 12, well that's a -4. And let's divide both sides by -24. And a negative divided by a negative is a positive. And we should probably reduce this. I don't think the SAT makes you reduce it. So when you enter your answer, you could have put 4/2/4 and bubbled those in. I like to reduce it though. 4 goes into both of these, 1/6. So I would have just put 1/6 on my bubbles. And that would be the answer for y.